Welcome to our YouTube channel, AdMaths plus Maths. We are now going through some problems about tangents and normals. Tangents and normals are already discussed in this lesson, in this YouTube channel in part 1. I am now doing this as part 2 to give you more examples of problems that might be involving tangents and normals. An example of that problem is this. I'll give you two problems this time. The tangent to the curve y equals x squared minus 5x plus 4 at points 1, 0 and 3, negative 2 meet at point Q. Find the coordinates of Q. So if you're going to notice, it's not saying or not telling us anything about normals. Okay? It's only referring to tangents. The first thing that you need to do is find out the gradient of the tangent by getting the derivative of the curve. After getting the derivative of the curve, you can find out the gradient of the tangents at point 1, 0 and at point 3, negative 2. After getting the gradient, okay, you can find out the equations of the two tangents, solve it simultaneously, then you will be able to find the coordinates of the intersection point, which is Q. So, let's start by getting the dy over dx of this. Okay? The dy over dx of x squared minus 5x is equivalent to 2x minus 5. Okay? As easy as that. So, it's at points 1, 0. So, therefore, at point 1, 0, okay, at point 1, 0, the gradient will be, okay, gradient will be equivalent to 2 times 1 minus 5. Okay, so gradient is equivalent now to negative 3. Okay, let's continue this by solving the equation of the tangent at point 1, 0. What is the formula? It is y minus y1. Y is 0 equals, the gradient is negative 3 times x minus x1. X minus x1 is 1. Thus, it will become y is equal to negative 3x plus 3. Therefore, it will become 3x plus y is equal to 3. This is the equation of the tangent that is at point 1, 0. Next, let's solve the equation or the gradient first at point 3, negative 2. After that, let's solve the equation of the tangent at point 3, negative 2. So, at point 3, negative 2. Okay? Gradient is equivalent now to 2 times 3. It's 2x minus 5. So, therefore, I'll take the value of the x. Okay? So, gradient at point 3, negative 2 is equivalent now to 6 minus 5 is 1. Thus, it will become 1 minus negative 2. Y minus y1 equals m is 1 times x minus 3, which is x sub 1 there. Okay, thus it will become y plus 2 equals x minus 3. Therefore, this will become negative x plus y equals negative 5. These are the two equations. I have 3x plus y equals 3 is the equation of the tangent at point 1, 0. And negative x plus y equals negative 5 is the equation of the tangent at point 3, negative 2. Okay? So what are we going to do now so that we can find the coordinates? solve the equations simultaneously. When you say simultaneously, I can do substitution, elimination, or graphing. Okay, so there are three methods you can use, but I'll be using the elimination method. I'll have 3x plus y equals to 3. I have negative x plus y is equal to negative 5. Elimination is if I will add or subtract, I can eliminate something. In here, if I add this or subtract this, I cannot eliminate. But these two, y and y, you see, y minus y, you can eliminate already the y. So y minus y eliminated. Okay? Next, 3x minus negative x is 3x plus x, basically. So it will become 4x is equal to 3 minus negative 5 is 3 plus 5, which is 8. So x now is equal to 2. So that's the x coordinate of Q. How about the y coordinate? You can substitute any of these two equations. Okay, substitute the value of x, which is 2, to those equations. So 3 times 2 plus y is equal to 3. Okay? Next, y is equal to 3 minus 6. Y minus 6, this is 3 times 2, is 6. Subtract both sides by 6, it will become 3 minus 6. So y is equal to negative 3. So this is the y coordinate. Okay? So the point or the coordinates of Q or point Q are 2 and negative 3. Let's move on to the next example. I have told you a while ago I'll be giving 2 examples. It will be a little bit more complicated, but let's try to solve it. Okay? A curve has an equation of y equals square root of x times the quantity of x minus 2 to the power of 3. Okay? The tangent at point P, 3 square root of 3, and the normal at the point Q, 9, 1, intersect at the point R. You see? Show that the equation of the tangent and the point P, 3 square root of 3, is this. Okay? So basically, we will just get the equation. Okay? But again, you cannot get the equation without you cannot get the equation of the tangent without getting the derivative of this, substituting the value of the x on the derivative. Okay? Then after that, you find out what will be the value of the m. Okay? So let's do that. Dy over dx. Remember, you take a look at this, it is equivalent to d over dx of, you see, let's not change it to dy over dx yet, that you don't get confused. Y is equal to bracket x to the power of 1 over 2. Okay? Then x minus 2, the quantity of that to the power of 3. Okay? So it means you are multiplying two functions. Thus, you will be using your product rule. Okay? Product rule says it's u derivative of v plus v derivative of u. Okay? Let's just recall that. d over dx of uv is equal to u dv plus v du. Okay? I hope this is clear. So this will become now dy over dx is equivalent to x to the power of 1/2 times dv. This one, the derivative of this. Okay? Let's put a big bracket. 3 times x minus 2 to the power of 2 times 1, supposed to be, but I won't write that anymore. Okay, it will make my working longer. Plus v. What is v? This one. X minus 2 to the power of 3. Okay, next. du. What is du? This one will be 1 over 2 times x to the power of negative 1 over 2. Okay, why negative 1 over 2? Because 1/2 minus 1 is negative 1/2. Okay, so again, this is u, this is dv, this is v, this is du. Okay, next. Let's simplify it, or actually you don't need to simplify it anymore. Okay, you can immediately change the value of the x to get the value of the m. Okay, what is the value of the x at that point? It is 3. So 3 to the power of 1/2 is the square root of 3. Okay, remember it's the square root of 3. Next, times 3 times 3 minus 2 to the power of 2 plus 3 minus 2 to the power of 3 times 1/2 times 3 to the power of negative 1/2. Okay, this one can be brought on the denominator. Let's bring it in the denominator. So this will become square root of 3. 3 to the power of negative 1/2. You bring it to the denominator, will become 3 to the power of 1/2. And then it will become square root. Okay, just like this one. So m now is equivalent to 3 minus 2 is 1. 1 squared is 1 times 3 is 3. So this will become 3 square root of 3 plus. Okay, 3 minus 2 is, what is 3 minus 2? 1. 1 cube is 1 times 1/2. So it will become 1 over 2. Okay, then over square root of 3, which is now multiplied by square root of 3, 1 over square root of 3, sorry. 1 over square root of 3, which is now 3 square root of 3 plus 1 over 2 square root of 3. Remember, you can add these two. Okay, so m is equivalent now to, this is over 1. This times this will become 6 square root of 9. What is the square root of 9? It will become 3. So 6 times 3 will become 18 plus 1 over 2 square root of 3. Okay, next, this will now become 19 over 2 square root of 3. Clear? Which will now become, you multiply it by square root of 3 over square root of 3. Okay, will become 19 square root of 3 over, what is square root of 3 times square root of 3? Let's put multiply. Square root of 3 times square root of 3 is square root of 9, which is 3. 3 times 2 is 6, you see? Okay, so that's the m. Okay, you know now that the m is equivalent to 19 square root of 3 over 6. Now, how will you find this number? Okay, you find that number when you substitute the value of, or the formula y minus y1 and show that this is the equation. Okay, you know already that the equation, the gradient of the line or the tangent is this. Okay. So remember that gradient because we will still be using that one later on. Okay. So this is the gradient. So y minus, what is y sub 1? Square root of 3. Equals now to the gradient 19 square root of 3 over 6 times x minus 3. Okay. So therefore it will become y minus square root of 3 equals 19 square root of 3 over 6x minus 3 times 19. 3 times 19 is 27. 57 square root of 3 over 6. Okay. Next. So therefore it will become y equals 19 square root of 3 over 6 x minus 57 square root of 3 over 6 plus square root of 3. Okay, you can add these two. Okay, you add those two, you will come up with y is equal to 19 square root of 3 over 6 x minus 17 square root of 3 over 2. So problem solved. Now let's move on to the next example. Problem. It says find the equation of the normal at the point 1, negative 1. So how are you going to do that? You know a while ago that dy over dx, I'm just basically rewriting this. Okay, dy over dx is equal to x to the power of 1/2. I have not supposed to be erase it a while ago so that you can still see. Times 3 times x minus 2 to the power of 2 plus x minus 2 to the power of 3 times 1/2 times x to the power of negative 1/2. So these are the things. This is our dy over dx. Remember, I told you a while ago, we have to remember the gradient of the first, but the gradient of the tangent here at point 3 square root of 3 has nothing to do with the gradient of the normal at point q 991. Why? Okay. Why? Because it's basically, okay, it's basically you don't have any relationship between those 2 points. Okay, because technically the tangent at this point is different from the tangent at this point. Okay, by the way, there is a typographical error over here. It's written here 91 and this is 1 negative 1. Don't mind that. This should be 1 negative 1. Okay, anyway, it doesn't matter because this is a separate question to that one. Okay, let's find the equation of the normal at the point q 1 negative 1. So if you want to find the equation, you have to find the gradient. How to find the gradient? Get the dy over dx, put in the 1, so 1 to the power of 1/2 is the square root of 1 times 3 times x minus or 1 minus 2, okay, squared plus 1 minus 2 cubed times 1/2, okay, you bring down square root of 1. Why did I bring down again? Because x to the power of negative 1/2, you bring it down, it will become x power of positive 1/2. And then you change the 1, add the x with 1, then power of 1/2 is squared, that's why square root of 1. So m is equal now to 1 minus 2 is negative 1, squared is 1. 1 times 3 is 3. 3 times, what is the square root of 1? 1. 3 times 1 is 3. Okay. Next, plus, or it might be minus. So negative 1, 1 minus 2 is negative 1. Cube is negative 1. Negative 1 times 1 half is negative 1 half. Divided by 1 is negative 1 half. So m here is equivalent to 3 minus 1 half is 5 over 2. Okay? So let's use that 5 over 2. It can also be 2.5. It doesn't matter. Okay? To plot in the equation of the line. Or, sorry, it should not be 5 over 2 because it should be a normal. Okay? It says, find the equation of a normal. So the equation of the gradient of the normal is 2 over negative 2 over 5. So we are dealing with normal. This is tangent. Okay? Next. So let's move on to y minus negative 1 equals, where did I get negative 1? This. Okay, equals to, okay, the gradient of the normal is negative 2 over 5 times x minus 1. Therefore, it will become y plus 1 equals now to negative 2 over 5x plus 2 over 5. This will become 2. Let's multiply everything by 5 so that it would be easier. So 5y plus 5 is equal now to negative 2x plus 2. You bring this one here, you bring 5 to the right, it will become 2x plus 5y is equal now to negative 3. This is now the equation of letter B. Thank you very much for watching this video. It's a little bit long video for now, but I hope you've learned something. Please continue supporting our YouTube channel and don't forget to like, comment, and share. For those who haven't subscribed yet, please subscribe. You will learn more in this channel. Thank you and God bless us all.